Hey guys, back today we're going to look at the factoring method today. So all that factoring we did last chapter, I'm going to be using it here today as well. Okay, now the factoring method we can use anytime it's factorable. Okay, so if you look at it and you can easily factor it, then we're going to use this method. Okay, again, we also have the graphing method from the other day and the square root method, so now you're going to have three methods after today. Okay, so the zero product property basically is based off, the factoring method is based off the zero product property, which says if you're multiplying two things and they equal zero, then you know at least one of them or both of them have to be zero. Okay, and you guys know that because if you multiply by zero, you end up with zero. Okay, so that's what we're basing it off of. Okay, it makes a whole lot more sense, I think, once you start getting into the examples. So we're going to jump into example 1 here. Now for example 1, they've already factored everything out for us. In example 2, we'll do the factoring as well. Okay, so we're just working on the new part of it. Okay, but after you factor it, you basically have three things that you're multiplying. 1, 2, 3. Okay, and out of those three things, we know that for it to equal 0, at least one of them has to be 0, if not more than one of them. Okay, so what we're going to do then is we want to find out what number makes it 0. Okay, what value for x makes it 0. So to do that, we really just set them equal to 0. Okay, so you're just going to set each of the factors that you end up with after you factor, set them equal to 0. Okay, so on this one then, if I solve, I would divide by -2, which would give me 0. That's one possible answer. On this one, I would add 5, and I would divide by 3. That gives me a second answer. Last one, I would add 6, and that gives me a possible answer. So that means this problem, because it had 3 different pieces when it was factored, has 3 different possible answers, and you need to have all 3. Okay, most of the time we'll have 2. You can have 3. You can even have more than that. Okay, sometimes you will have 1 as well. Okay, but just know that, okay, however many pieces you end up with, okay, that's typically how many answers you're going to end up with as well. Okay, so the first step will be factoring. Okay, and then after it's factored, setting those factors equal to 0. Okay, we have one more under the example 1 as well with our b. Okay, this time they give you x minus 3, and they give you 2x plus 7. Okay, 2 different pieces, which means I'm going to have 2 different answers. Okay, so that means I want to set each of these equal to 0. This one I would add 3, so that becomes an answer. This one I would subtract 7 and divide by 2. So that becomes a possible answer as well. So that one would have 2 answers. Okay, so if you were to graph these in your calculator, you would see that they cross the x-axis at this point. Okay, it's just a different way to do it. Again, a lot of times we're going to end up with decimals, okay, which is why we don't use the graphing method with these. All right, so let's go ahead and look at example 2, which kind of puts it all together then. Okay, notice the directions say solve by factoring. So we want to factor first, and then we can set them equal to 0 and solve. So the first one you have is x squared minus x minus 12. Notice it does equal 0. You cannot factor until it equals 0. Okay, so if you had stuff on both sides, you need to get it all to one side so you can factor. Again, still look for GCF first. There's no GCF, so we'll go to our 2 parentheses. So for the x squared, I would have x and x. I need factors of -12 that give me a -1. Okay, so it would end up being -4 and +3. The exact same factoring you did most of chapter 8. Okay, I have 2 different pieces, which means I'm going to have 2 different answers. So I set each of those equal to 0. I get x equals 4 as one answer, x equals -3 as my other answer when I solve. Okay, and that's really the only new part. So as long as you were pretty good with the factoring from before, this method is not very hard. Okay, if you struggled with factoring, then you may want to go back and look at it, because factoring is a huge part of Algebra 2, and we even do some of it in geometry as well. Alright, so for the next one, you'll notice it's not set equal to 0. I need to set it equal to 0, so I need to add the 4 to this side. Very important as well that it's in standard form. Okay, I need to go squared term, regular x, and then number by itself. Okay, so again, look GCF, and we don't have one, so we'll go ahead and factor. 3 is prime, which remember is nice, because then 3 and 1 are our only options. Both signs would be positive. And we got the option of 4 and 1 or 2 and 2. Okay, so again, you'd have to try it out. This time it does end up being 1 and 4. Remember, you check it by going 1x, 12x, add those together, does give me 13x in the middle. Again, if you need to look back at your notes about factoring, please do so. Okay, I have 2 different parentheses, which means I'm going to have 2 different answers. Subtract the 1 and divide by 3. Subtract the 4. And that would be our 2 answers for this one. Alright, so for the next one, again, you'll notice it's not set equal to 0, so that is the first thing we need to do. I will tell you, having the x squared term positive makes factoring a lot easier. Okay, so I'm going to add the 2x squared over here, and I'm going to add the 14 over here. Okay, it makes it easier to factor if you have a positive x squared. Okay, look for GCF. I do have one here. It's a 2, so I'm going to pull that out first. And now I'm going to factor what's on the inside. Again, 7's prime, which is nice because I'll just get 7 and 1, plus and plus. Options are 1 and 8 and 4 and 2. Looks like 4 and 2 is going to be the correct combination. You'll get 14x and 4x, which does add to 18x in the middle. Now, what you have to look at is where your x is at. You'll notice I do have a term out here, but it doesn't have an x with it. If it doesn't have an x with it, I can't use it because I'm just going to end up with 2 equals 0, which we know is not true. Okay, so if your GCF does not have an x with it, then we will not use it for an answer. So subtract your 7 and divide by 4. Subtract your 1 and divide by 2. And those would be your 2 answers. Again, can't use the GCF because it does not have a variable with it. And one last one here, hopefully kind of getting the hang of it. So again, we're going to want to set it equal to 0, so I'm going to subtract the 5k to the other side. We have a GCF of k that needs to get pulled out. And then we'll factor what's left over. 5 is prime, which is nice. Again, we're going to have 5 and 1. I'm going to have opposite signs because of the negative 5. And then I've got either 1 and 6 or 2 and 3. Looks like 2 and 3 is going to be the correct combination for this one. You'll get 15k minus 2k, which would give me my 13. Now this time the GCF does have a variable, so I will keep that as one of the answers. So k equals 0. And then I'll set up the other two. So I'd subtract my 5 and divide. Add my 1 and divide. So this one ends up having 3 answers because there's 3 different k values that we have. All right? So again, if you need to look back at your factoring stuff, please do that. Might be necessary for some of you just because we haven't factored in a little while, just to kind of remember the rules and everything else. Tomorrow you'll do a worksheet just kind of practicing the square root method and the factoring methods. We won't learn anything new tomorrow. And then we'll get into 2 more methods that we have after that. So have a great rest of your day.